Hi, everyone. Las Positas College has been collecting a number of data sets on the north side of campus. And hopefully today we can take a look at those data sets and maybe answer some questions around sustainability. The drone program has two types of drones we've been using lately. One's it has a thermal sensor, another has a multispectral sensor. And these data sets, as you can see from our website, can be used to better understand green areas on our campus versus non-green areas. You can better understand building performance, where heat is gained, where heat is lost, these kinds of questions. So there's a lot of things we can do with drones to understand questions around sustainability. Now, one things we really do like to do on the drone program is play with the data, and that's what we're going to do today. You can click on these links, download the data, and then using this program here called QGIS, we can visualize the data and then do some basic analysis on it to, again, ask questions about sustainability. So let's do that. So QGIS is essentially a mapping program where you can bring in data that is georeferenced. Since the drones use GPS to fly, each image is spatially recognized, right? It knows where it lives in space. So this is the thermal image, the thermal data set. It comes in grayscale, right? And has a value of -27 to 91, right? And that means that each pixel, if we go all the way down into, see how it's getting each pixel is a square, right? And if we go here and use this little identify feature value, we click on it, it says that little square is 28, and maybe the next one over here, boom, is 19. So again, you can see the difference in temperature value between one pixel and the rest, right? And it's just grayscale, right? It doesn't really look very good, but you can definitely understand that just each pixel has a value attached with it, right? And so we can see the value of our field, right? Our athletic field here is 37, or our road here, which is 48, right? It's a big temperature difference between asphalt and our grass field, right? Now, it's really helpful to kind of visualize it a little bit easier. So on the right-hand side, there's the browser, but there's also layer styling. So again, we can, instead of a single gray, we can use a pseudo color. My ramp is already set to, again, you over here, or choose our color ramp. I think I have it set to Inferno, right? Cool. So now it's like dark is the coldest, and then this yellow red is the hottest, right? Cool. So again, you can see areas like the grassy field around our athletic stadium is one temperature, and our track itself is another temperature, which is hotter. Hotter on the track, cooler in the grass. Now, looking at our layer styling here, there's also a series of tabs. So that is symbology, transparency, labels, if you want to label things, and here's histogram. Now, I've already actually computed the histogram. There's a compute button there, and you can set your minimum and maximum. Let's do that right now. I'm going to pick my minimum. I'm going to put it right here, and I'm going to do my maximum and maybe up in this area here, right? So again, this is our histogram, and it basically just shows our a range of values, and the vast majority are right here and in this grouping. So we can cut off the lower ones and the upper ones, and then it kind of pops things a little bit differently, right? Then if we go back up to styling, then we can kind of get a sense of where things are at, right? So this is very useful for us just to get a sense of, again, the cooler areas at 37 and the hotter areas at 61. And again, these are kind of relative values. This was a hot day in which we were flying over, but gets a sense of where things are cool versus where things are not, right? Cool. Okay, so that's our thermal data. Let's take a look at our multispectral data. If you're wondering what multispectral data is, you can go to our website and zoom around, and I can show you what that is. Let's see. I think it's this one. I'm going to drop it in there. No, it's not that one. Let's try this one here. No, it's not that one. This one here. Yeah, there we go. Sorry, I get a lot of data here, so I'm going to get rid of these. Just going to remove those. Boom. Okay, so this is our multispectral data. Again, if you need a reminder, you can go to our drone website here, and you can click on drones and agriculture, right? And it kind of explains what the multispectral is. Essentially, it's if we think of color light has it's a mixture of blue, green, red, and of course non-visible light of infrared. So essentially, this image that you're going to see in a second plays with red and the near infrared. And essentially, it highlights areas that where vegetation exists and where there's non-vegetation. So it's kind of again, agricultural index, vegetation versus non-vegetation, essentially things that absorb or reject infrared light. And so like the first image, this is also comes in as grayscale. So it's negative 0.65 to 0.91. Again, this is an index. So it's -1 to +1. So again, on our layer styling, we're going to select, again, not our thermal, but our quest. And then instead of a single gray, we're going to use a pseudo color. And we're not going to use the thermal. That's because this is an ag index. So we're going to go to all color lamps. I think I'm going to go from, I like red, yellow, and green. Boom. There. Okay, cool. So again, this is a range from green, which means vegetated, to red, meaning not vegetated. And we're going to declick that thermal image in the background. Okay, so again, just like we did with thermal image, we can go to histogram, compute the histogram. We can use the little hand here and go to the minimum, put the minimum there, and then the maximum, again, we're going to put it over here. Go. Right, and maybe we need to pull this out just a little bit so I can see things a little clearer. Cool. So now we get our minimum at 0.2, our maximum at 0.2. Now when we see this image, we can really see this idea, oh, there's the grass, there's the track, there's the kind of open space grassland versus areas that we're watering a lot, right, that we actually have water systems. We use reclaimed water. Again, if you want to zoom around, you can zoom out and then put the cursor and zoom in. You can also use the hand to move around, whatever you'd like to do. Okay, so with that being said, other things that we can do is doing some really quick kind of, not analysis, but getting to know our areas. Now, this is, if you see that we have a kind of a range of values here, right? 0.96. Instead of continuous, we can do equal interval, and we can even put the number of classes there, right? I have 5 classes here. You see it's kind of broken down here. And this really is actually quite useful. We can really distinguish between vegetation versus non-vegetation. Now, maybe we want to calculate non-vegetated areas, right? And let's say that our non-vegetated, if you, again, look at our values over here, anything 0.786 and above is essentially, looks to me like vegetation, right? So let's try to extract that out really quickly. How do we do that? Well, there's this thing called a raster calculator, right? And we can put in any kind of expression here. So let's do I'm going to put a close parentheses. Actually, yeah, close parentheses. You double click on the raster that you're going to use, the image. So that, and let's say we want every value that is greater than, what was it again here? 0.786, 0.786, boom. And then we can, output layer, you click the three dots. We're going to save it, again, I'm kind of lazy. These are what are called classes, like a series of classes. We're going to go, I always like to 786, right? So that's class 1786. We're going to save that and we're going to run it, right? And this is going to run, and essentially it's going to extract out and isolate out all the values that are above 0.786, right? And this is useful for, again, starting to look around, and we can choose values that indicate a road, a building, asphalt, healthy plants, non-healthy plants, dense vegetation, sparse vegetation, these kinds of things. So these are tools that we use in satellite imagery. Cool. Okay, so again, we can just ignore these. So what's this? Again, if we click this off, 0 is the dark, 1 is the is those kind of vegetated areas, right? So again, you can see that we've extracted out. This is a little bit weird to see, and I think that one thing that's very helpful, if we get rid of the zeros, like the no value, we can actually go into here. Yeah, see additional no value, set that to 0. And then if we go to the top of the single band gray, and you can go to single color. Bam, there we go. Now what we have is all these, that is all the vegetation that comes up that we've kind of extracted out of our, our area. Now, a couple of things we could do is continue to use the raster calculator here and say, you know what, we're going to take that value and we're going to do greater than 0, right? Oops, greater than 0. And we're going to hit this. Is it 86, right? And we're going to call it no zeros, right? We're going to hit save. We're going to hit that. We're going to let that run, right? So again, we're starting to kind of interrogate this multispectral imagery as a way to understand which values have certain meaning, right? And maybe I'm trying to wonder what the question is, like, how much vegetation do we have on our campus? Maybe that's the question we're trying to answer here, right? I'm going to let this run for a second, see how it goes. Boom, boom, boom. Just about done. There's other things. Again, keep looking at this image and trying to classify which, what do we see here? What do those values indicate? What do they represent? That's the idea. Okay. Again, you can deselect this one. Here's this class here. Now you can see it comes in. There's no issue. It's just 1 and 1. No zeros. Now you can again see that is all the kind of vegetated areas, or at least everything of that range of 0.786 and above, right? Kind of cool. I like that. Now let's try to answer percentage. Like, what do we think is the percentage of our green versus our actually wider campus? Everyone can place a bet on what you think the percentage of our vegetated area versus our non-vegetative areas. Okay, how much do you think it is? Let's find out. Okay, so to do that, we can answer a simple question. We're going to click on our Quest multispectral image. Again, we can go to our processing toolbox, and we're going to search for our raster layer statistics. There it is. Boom. So again, what is this? We're just going to get some statistics out about that image here. It's called a raster. Hit this. We're going to save to a temporary file, save to file. And then I've already done this. I practiced this, right? We're going to do 7, 8. Just the total thing. We're going to do the total of the MS image, right? We can call it, I don't know, total, right? And we hit save and we do run, right? Again, it might take a while to run, right? And what that basically is doing is going through and counting each one of the pixels in that raster image. And there is a lot in that raster image, right? Just a lot. So there we go. So you can see actually here it is. The total number is 700 and oh my gosh, how much is there? That's 100,000. 833 million pixels, right? You can just copy that for fun. You can put it in a spreadsheet here, right? And I can do a new spreadsheet. Boom. Paste, right? So there's 80, again, that's a large number, right? Cool. And yeah. Oh, actually, that's the count. The sum. Okay. And then let's do the same thing. And actually, this is what the file looks like, by the way. We're going to open that with Firefox. Yeah, there is actually all the numbers. There's the count. Oh, the count of the non-pixel data is 8. No, the sum, that's actually the number that we want right there, 46. We're going to copy that, and we're going to stick it in our little book there. That's the number we want. Great, cool. So that is the total number of pixels in the raster. Okay, let's spell raster correctly. Raster, okay, cool. Now, let's look at our vegetated area that we got here, right? You get where I'm going with this, right? Let's go to parameters. Instead of choosing that, let's choose our non-zeros, right? We're going to do the same thing. We're going to save to file, and we're going to call it 786, no zeros, but slightly different. 78686. Boom, boom. Okay, and we're going to run that. Okay. Let that run and see what happens, right? Again, what we're doing now is we are just counting these number of pixels, right? So again, we're going to let that go. I know I'm letting my computers really struggling here, but that's okay. Again, there's like, how many pixels? And then the last one, there was 464,195,065 pixels. Whew, that's just a lot. There we go. Okay, so now that's done. And the sum was not that number right there. We can just grab that number out, right? Close this. Again, we can go to our file to see what that 786 was. No zeros. I should have just clicked it on there. There we go. We can also just open that Firefox, and then there's our sum right there. We can grab that out. Okay, cool. Now we can go back into here, into our Excel sheet. Put that number there. And so this number is of our vegetation, campus vegetation, right? So how do we get the percentage, right? We basically go make a simple formula equals this number divided by this number equals 0.98, right? And then if you want to do a percentage, right, you can do equals this number, right, times 100, bam, right? So essentially, that is 19% of our total, in this part of campus, is vegetated, right? Again, that's the vegetation. And so that's how you can kind of run some really basic statistics here, right? Is using the raster calculator. The same thing is true is that you can run ranges, right? Like, for example, if we do one last thing, maybe we want to look at, again, go to our layer styling. If we want to, say we want to capture the orange 0.46 to 59. Again, you can go to raster calculator. We can go parentheses West MLC C, and we can say we want the values that are greater than, what do we say here? Greater than 0.406, close parentheses, Boolean query, and again, parentheses, 0.46, boom, less than, right? Less than 0.596, right? Boom. Okay, cool. And then you hit, you can save it. Again, maybe we're going to call this class 2, right? We're going to call it another class. And that essentially is values between, what is it here? 0.4 to 0.6, 4 to 6. We should make some notes on this. We hit that and hit OK. And then we let that run, right? So again, the same idea is that you can isolate values and start classifying this area, then ask questions about percentage. And that's a simple way to kind of begin to interrogate the data. Okay, everyone. That's the beginning of how you begin to look at the data, try to understand what it represents. And then after you do this, then we can talk about relationships, right? I hope that everyone is able to navigate around, look at our data sets. Maybe as groups, you can ask some, oops, sorry about that. You can ask some questions and give us some feedback and help us better understand issues around sustainability on our campus. Woof, there we go. Look at that. Totally cool. Love this. Fun data set. Okay, everyone. Have a great day. Take care. Bye.